Hello, first we're going to do problem 58, which is a problem of differentiation by definition using only this formula. And now we're going to solve these parentheses with this formula that I already know by memory, and everyone should already know by memory. Okay. Now we close the parentheses and we insert this. And all of this, of course, divided by h. Now I'm going to solve these parentheses, then this parentheses, then that. Okay, so it starts with an 4x to the third plus 12, because 4 times 3 equals 12, x to h plus 4 times 3 equals 12, plus 4 times 1 equals 4, minus 2 times x equals minus 2x, the same with the h, minus 2h, plus pi, and then this, the negative affects every one of those. So we have a negative 4x to the third, then a negative times a negative is a positive, so positive 2x, then a negative and a positive is a negative, so negative pi. And all of this, of course, divided by h. And now what we're going to do is that we're going to cancel the ones that add and then subtract themselves. So 4x3 minus negative 4x3 equals 0. And then we have here a plus pi and a negative pi, so that's equal to 0. And then we have negative 2x, and here we have a positive 2x. And all of this which is remaining, I'm going to write it down here as 12x2h plus 12xh2, I mean to the second power, plus 4h to the third power minus 2h, all of which would be divided by h. We have this, we are going to simplify, taking out the h, which is possible because all of these four numbers have an h inside them, and you can take it out and simplify. So I'm going to do h, 12x to the second plus 12x to h plus 4h to the second minus 2. All of which would be divided by h. And now what we are going to do is we're going to cancel this h with this h, which only leaves us this. So we are going to insert 0 into our formulas, which would be here, all of this multiplied by 0, which would cancel itself. And also over here, 0 to the second power times 4, 0. So we are left with equals 12x to the second minus 2. This is our answer, but written in proper notation, it would mean the limit of h0 equals, and that is our final answer.
Okay, here we have our problem of finding the limit when x tends to 0. And we're going to solve it algebraically, because if we plug in the 0 here, it would be undefined, and we can have a 0 on the denominator. So first, we start by multiplying by the reciprocal, doing difference of squares. We change the sign, and that leaves us with x plus 2 minus 2, because the squares are gone, divided by 3x. This times this is 3x, open parentheses, x plus 2, plus square root of 2, close parentheses. Here, 2 minus 2 is 0, so that leaves us with x over 3x, open parentheses, x plus 2, plus square root of 2. Here we can cancel out the x's, and after we cancel out the x's simplifying, it's 1 over 3, and now we can plug in our 0, leaving us with 0 plus 2 plus square root of 2. We're going to simplify it by having only 3 times square root of 2, because 0 plus 2 is 2, plus 3 square root of 2, because 3 times square root of 2 is this. And that we can simplify it by having 6 over square root of 2, because since this and this is the same as having 3 times 2 square root of 2, and this multiply, leaving us with 6 square root of 2. And that we plug it in our calculator, leaving us with 1 over 6 square root of 2. It's square root of 2 divided by 12, and in decimals is 0.118. And this, writing it in proper notation, would be limit with x tends to 0 is equal to 0.118. And that is our final answer.
Here we can check our answer by solving it graphically. When we place here our equation, when x tends to 0, we can clearly see that our answer is 0.11788, rounding it to the third decimal, 0.118.